Okay, yesterday we saw the chain rule, which allows us to differentiate a little bit easier. We're going to look at a couple more rules today. Product rule. So if you've got something and it's factorised, so you've got two functions of x multiplied together. At the moment, of course, we're just dealing with polynomials, but later on we might see things like x times the sine of x or something like that. So in that case, we wouldn't be able to expand it out. So we need a rule to deal with that. This is the formal rule. So u and v are both functions of x, and it's saying, well, okay, well, first of all, we'll differentiate the second term there, so the v, and then we'll differentiate the first term. Basically, you can expand that idea. If you had several products, all you really do is in each one, you just differentiate one of the terms that's being multiplied each time. I personally think of it this way. Write down the first, diff the second, plus write down the second, diff the first. You can impress people too by the speed you can say it too. But again, it's similar to yesterday's rule, right? Bring down the power, lower the power, diff the inside. What you're basically saying is what you're doing. So as you do it, you say it, it makes it a lot easier. So here we go. Yes, I could expand that out, but let's look at this as an example of the rule. I've got two functions here, x to the power of 7, and the other one's x to the power of 9 minus 6. So I write down the first, x to the 7, diff the second, so the second bit, 9x to the power of 8, plus write down the second, x to the 9 minus 6, diff the first, that becomes 7x to the 6. So I do it as I say it in my head or out loud if you really want to impress people, but it gets it down. You don't have to worry about what's that formula, uv dash plus uv. Just do it this way. Now let's tidy that up, and we get, oh, actually that can go a bit further, and there's our answer. Let's do another one. So again, yes, I could expand it out, but for the sake of the example, write down the first, x minus 2, diff the second, 2, plus write down the second, 2x minus 3, diff the first, 1. And then we just tidy that up and we get our derivative. ddx, so the other notation, but again, it's a product of two things. So write down the first, x to the 7 minus x cubed, diff the second, we get 6x, plus write down the second, 3x squared plus 7, diff the first, 7x 6 minus 3x squared. Tidying all that one up, I come up with our derivative. Now, a lot of these, it actually would be quicker to expand out first. But we're sort of trapped at the moment with what we know how to differentiate. As I say, once we get to looking at trig functions and log functions and that, we'll have no choice. We'll have to use this rule. Okay, 3x times x squared plus 4 to the power of 5. See now, yeah, to expand this one out would be a hassle. And remember, the whole point of the chain rule yesterday was to make the differentiating with the power a lot easier. So this one, if I combine the two rules together, it'll make life a bit easier. So write down the first, 3x. Diff the second. Well, the second is x squared plus 4 to the power of 5. So I'm going to use my chain rule to differentiate that. Bring down the power, 5. Lower the power, 4. Diff the inside. So the inside's x squared plus 4, 2x. Plus, write down the second, x squared plus 4 to the power of 5. Diff the first, 3. All right, tidying the first bit up, but we've got some common factors there. X squared plus 4 to the power of 4. Oh, and 3 as well. So let's factorise all that. For some reason, I didn't take the 3 out. Wonder why I didn't do that. Oh, I left it to the last step. Okay. Either way, I've still factorised the 3 out. Surds, I've got no choice this time, so this is one of those ones where I've got to use the rule. Write it in index form, 2x minus 1 to the power of a half. Write down the first, 2x. Diff the second. Bring down the power, half. Lower the power, minus a half. Diff the inside, 2. Plus, write down the second, so 2x minus 1 to the power of a half. Diff the first, 2. What have we got? 2x minus 1 to the minus a half. Plus 2x minus 1 to the positive a half. That factorises. I've got 2 in both of them. Remember, when we've got powers, it's always the lower power. It doesn't matter if it's negative. So 2x minus 1 to the power of negative a half would be the common factor there. So 2x minus 1 to the negative half, leaving me with x plus 2x minus 1. which there's the mere mortal answer. There's the super mathematician answer. Yeah. Looks much more impressive, doesn't it? Okay. So 7F is all on our product rule.